Well, thank you very much. Good afternoon, everyone. It's very early in the morning here, so if I'm not as animated as usual, you'll know why. I want to talk to you today about some visions of the future of software and also point the way to how we might get there. But I'm warning you now that there's going to be a lot more in the presentation that I will be giving live in November, so we shall proceed. So 20 years ago, which isn't that long ago in the grand scheme of things, but in technology terms it is generations, it seems. 20 years ago I knew less than 10 people with email addresses. This is 1988. Probably all of those people that I knew with email addresses sat within a 20-foot radius of my desk, and the idea of emailing them was pretty much not even necessary. And if any of you have ever are old enough to have UU encoded and UU and decoded email attachments, you'll know not only was it not necessary, it was a real pain in the butt. 20 years ago, no one I knew ever asked me to fix their computer. 20 years ago, everyone I knew who used computers knew as much about them as I did, and the idea of having me help them was simply unnecessary. And now if you look at the future, everyone I know, particularly maybe it's because I work for Microsoft, I don't know, everyone asks me to fix their computer. This is a little bit disconcerting. Not only is everyone's computer broken, most people I know aren't capable of fixing it themselves. I see that as a problem. And 20 years ago, I never had to reboot toys, phones, picture frames, tools, dog collars, cable boxes, because none of these things had software in them, and they all worked just fine. But now, 20 years later, all of these things do have software, and they seem to be broken pretty much all the time. Today, things are a bit different. Today, by the time you make breakfast and drive to work and make it to your office, millions of lines of code have executed on your behalf. I want to emphasize that. Millions of lines of code have executed on your behalf. So it's 6:15 a.m. right now in the state of Washington, where I live, and I'm sure that this is true even though I've only been awake for about an hour and a half. Today, things are different. Consider that your finances, your travel information, your traffic violations, criminal history, citizenship, medical records, organization memberships are all stored in and processed by software. I emphasize they are all stored in and processed by software. Software is basically in control of every piece of information that makes us uniquely us. And this is worrisome, because all of that personal information is stored literally on hundreds or even thousands of computers all over the world. We don't know where these computers are. We don't know who has access to these computers. We don't know how well they're protected. We don't know their security schemas. We don't understand their reliability. All we know is that our information is stored literally everywhere. And let's not forget that food doesn't get on our grocery store shelves without software being in the mix. Software used to control the growing of food, the distribution of food. In fact, distribution in general is so controlled by software that most places like FedEx and UPS in the United States will readily admit that if their computers go down, packages will not be delivered. Food will be rotting in the warehouses if software isn't part of the solution. Nuclear power, advanced weapons are controlled by software. Airplanes take off and land by the good graces of software. The people working on curing cancer, countering climate change, controlling disease, finding killer asteroids are all depending on software for their productivity, for their systems to work. They build modeling software. They build what-if analyses. Do we actually want the people who may be responsible for terraforming the atmosphere of this planet in 20 to 50 years to not have access to software to analyze all the different possible variables, all the different possible combinations, and what the side effects of their work might be? If you take software out of the equation for any of these people, the doctors working on curing cancer, the scientists working on countering global climate change, etc., these problems become intractable. They become so difficult that we won't be able to solve them. Software is not only pervasive in our present, it's part of our future. Now, this is a little bit scary because this is the type of software that we've gotten our users focused on and using. This is a little bug I call, actually, I don't know how to say, Daddy, are we there yet in Norwegian, but it seems to me that this is sort of an inconvenient route between southern and northern Norway. And I suspect, I haven't confirmed this, but I suspect that we have a bit of a problem here in two specific features. There's the pub crawl through England starting in Newcastle feature, which seems to be conflicting somewhat with the if the wife is in the car, don't drive through Amsterdam feature, and we end up with a nearly 2,000-mile route between two cities in Norway. Yes, this is the present of software. Here's a nice little bug. Here we have a system where most likely the people who make the libraries and the compilers for web applications have made money on this. The person who wrote this and supplied it to the hotels has made money on it. And then the hotel that sells this technology, this web access to their guests, make money on it. We have a lot of people depending on this particular piece of software for their livelihood. And if you look real close at that, there is a CGI parameter called fee. You may as well call it free, because I could think that it says fee equal $8.95, but actually I would prefer fee equals 0.00, and that's all you have to do is edit that number, 8.95, and you get free internet access. Now, it turns out if you delete the parameter, you bring down the web server, which means you've just done a denial of service attack on web access for anyone in this particular hotel. Now, if you're really clever, you might think that what if you enter a negative number in there, and it turns out that you really can get a cheap hotel. So these are a series of bugs I'm showing you that are all too real and inconveniencing users of modern software. Here's a nice little error message. I think that you have to pronounce the OK button as the OK button in order for this one to actually make sense. I like this one. When my kids tell me they have nothing to do, I tell them to go outside and play. I don't know what to tell my software when it tells me it has nothing to do. Sometimes our error messages lack specificity, shall we say. And just when we think they're as unspecific as they can possibly get, we actually make them less specific. Sometimes we make them a little too specific. This one may as well say, hint to hacker, you're getting warm. And just in case the hacker is not smart enough to find the bug, sometimes we simply tell them where it is as if we feel sorry for them in their plight. And finally, this is ranking as my current favorite error message of all time. We'll see if I find one that's more favorite by November during my keynote. This one says, an error has occurred while displaying the error that has occurred while creating an error report. Funny enough, this error message comes from Live Meeting, which is the application we're all using, hopefully successfully, right now. I don't know how this error message got written, but a human being was sitting in Visual Studio or in some IDE and actually typed this in. Most likely that same human being, let's call them a developer, not only typed it in, but reread it because the grammar, while being sort of oddly recursive, is actually correct. And I can also imagine a tester finding this bug, reporting it to said developer, and the developer saying, oh yeah, you're right, I forgot the period at the end of the sentence. So these are the little gifts that our profession of software development has given humanity. It worries me a great deal that these sorts of bugs not only exist in modern software, but they persist in modern software. They are everywhere. Next time you're anywhere where there's a gathering of people, ask that crowd of people, how many of you use software? They will all raise their hands. Maybe there are some crowds on this planet to which you might address who haven't used software, but they are going to be very difficult to find. Now ask that same crowd of people, how many of you have experienced that software doing something that just pissed you off? Software fails, and we've all experienced it. Everyone has experienced it, and no matter what crowd of people you address, they will have not only used software, they would have been abused by software as well. It is one of the most frustrating aspects of modern society. Now, this same software that we see failing on a regular basis is being used by the people who are working on cures for cancer. It's being used by the people trying to find killer asteroids. It's being used by the people trying to invent the technology that will give comfort to an overpopulated and an overextended planet. I don't know how many of you out there are disturbed by this, but I am. When we see a future, and by the way, in November, I am going to show you a video of Bill Gates' vision of the future of software that I think you'll enjoy. When we look at what software will be like in another 20 years and how much more it will pervade society, the idea that bugs like this can be so easy to create and exist and persist for so long within the ecosystem, we really get to a situation that's not only unacceptable, it's actually dangerous, and we need to do something about it. So 20 years from now, software will be everywhere. There will be radio frequency IDs in pretty much everything we buy and everything that we do. Now, what is the role of the software tester in this future? These are the questions I'm going to be trying to answer in November when I give my actual keynote. Let me give you a summary of some of my ideas. 3 specifically. Information, visualization, and the time in which bugs persist within software, I see as 3 of the most fundamental problems that we have to deal with as an industry of software testers. We are the gatekeepers of this quality. So we have a role to play in making sure that software ships and ships with high quality. So I'm just going to summarize my vision of each of these 3 problems, a vision of the solution for each of these 3 problems, and give a lot more detail in November and maybe even add 1 or 2 new solutions. Let's talk about information at first. Now, information is generally something that is the lifeblood of software testing. Either we have information or we don't have information. And generally, for the case of software testing, we don't have the information that we need. So you see two screen snaps on the screen right now from the World of Warcraft, which is an incredibly popular game in the United States and I'm sure in Europe as well. On the left, you have the World of Warcraft without the heads-up display. On the right, you have the World of Warcraft with the heads-up display. Now, on the left, without the heads-up display, this is a very good way of getting yourself killed playing this game. You don't have your tools. You don't know what's coming. You don't have any information about the world in which you're interacting. The chances of you getting killed without the heads-up display are very, very high. I like to relate this to software testing, and that is testing without the information that you need to find and report bugs and to understand what the application is supposed to be doing. It's a good way to get yourself killed as a software tester as well. Not killed in the physical sense, but killed in the sense that you're unproductive, you can't find bugs, and the application looks like it's succeeding even when it's failing. If you take a look at that heads-up display and the information that it contains, this is the same sort of information we need as software testers, right? There's information about you, about your avatar, about your character. There's information about the targets, the other things that you're interacting with in the environment. There's, in the upper right-hand corner, this little mini map of the world that sort of shows you, you are here, And these are all the different possible places that you could go from here. And then on the bottoms, there's quick access to your tools, your abilities, your weapons, and things that you need to take care of the things that are in the world out there. Now, in software testing, we generally test without this sort of information. Wouldn't it be nice to have a little mini map in the upper right-hand corner of your screen when you're testing an application so that you know this input's going to take you here, this input's going to take you here. There's uncovered code this direction, but there's not uncovered code in this other direction. We're testing right now without that context. What would those tools look like? What is the abilities bar of a software tester? What are the common tools that we should have available as we are testing? Not something that I bring in later for some analysis, but having all that analysis packaged in a heads-up display for software testers. I'm going to show you in November what my heads-up display looks like when I test, and maybe I'll get you excited enough about it that you'll build your own or adopt one as well. Now, here's the fundamental problem with information in software testing. We have these 4 roles at Microsoft, and many of you may call them something else, but you generally have the same roles in your software development. We have architects that see Visio diagrams, flow charts. They think in terms of data flow and dependencies and connections. We have program managers who see PowerPoint decks and Word storyboards. They think in terms of features. Developers who see Visual Studio, they think in terms of source code. And developers who see binaries and interfaces, they think in terms of UIs and APIs. All of these 4 roles see different sets of information while they're testing software. They don't always see the same thing. So that the tester sees what they claim to be a bug, give it to a developer, the developer is going to have a completely different viewpoint of the application. And they may not see that as a bug whatsoever. And from their vantage point of the source code, they may actually be right. So the idea that we don't share enough information, that I as a software tester can't see the source code while I'm testing, I don't need to, I need to rely on it. It doesn't need to be the only thing I use, but it would be nice to be able to hover over a UI control, particularly for a web application, be able to see the HTML and JavaScript underneath, be able to see things like the data type of the input that I'm entering into the system, to be able to see the architecture diagram overlaid with the source code, overlaid with the interface, so that I can consume and use and rely on all of the information embedded into this software application that I have access to. I'd like to be able to see it all and use it all at the same time. So that's information. From where I sit, all of the architecture information, design information, and code are useful to testers in the right context. All of that information can be used to make us more productive and to, if presented to the software tester in the right way, can allow us to see bugs when they're happening at the actual point at which the software fails, as opposed to 10 minutes later when the failure actually manifests as something that we can see through the interface. I'd like to be able to see all that stuff whenever I want and in a form that testers can consume. I don't need an architecture diagram that only an architecture nerd can read. I don't need to see the source code in all its gory details. I need to see summaries of it. I need to see data types, etc. So as software testers, we need to get our heads around this. We need to understand what information is available to us and in what format it will be helpful to us. And I'm going to have visualizations of this in November when I come and give my actual keynote. So that's information. And now visualization. So I'm showing there are 4 pictures from an automobile manufacturing plant. I actually think the bottom one is an Audi, but I'm not positive. So my father, for 30 years, built cars for Ford Motor Company. This is what he did. And in fact, he was a tester. He was a QA manager on the assembly line. So my father could walk down the assembly line, and he could see a car. He could see that the car was broken. He could call a repair person over, and the repair person would look at the car. They could both stand there together and look at the car. And they could agree, hey, look at that bolt. That bolt's broken. And the repair guy could say, yep, you're right. That bolt is broken. I'll fix it. And then the repair guy could fix it. My father could look at it and say, hey, you fixed it. Well done. Let's restart the assembly line. The key point here is that both the tester and the developer, the repair person, whatever you want to call them, have the same visual image of this thing that they're building. They both see the car. They both see the bolt. They both see windows and engines and wheels. They have the same representation, the same visualization of this product that we're building. We don't have this in software. What does software look like? Well, software is basically magnetic fluctuations on media that we can't and don't see. You know, the reality of software isn't helpful to us trying to build it. We're really one of the few industries that can't see the product that we're building until it's built, right? It's invisible. Source code doesn't look like anything useful until it's actually compiled and into a binary. Why is this? And must this be the case? Are there visualizations out there that would actually help us to build software and to build it more reliably because we can get it into our head? Well, I think there are, and I'm going to share with you in November a bunch of visualizations that we use at Microsoft to help us manage this. So a little preview, here's two of them that are on the screen now. The one on the left is a visualization that our Xbox team uses. This is from a game that we recently shipped called Project Gotham Racing. In the Xbox land, almost all of the testing is done manually, right? People play the game. They play the game based on scripts. They play the game based on scenarios. Here's a scenario we want you to test, and then the manual tester tests it. And then we also do a lot of exploratory testing because there are a lot of things about the game, usability and fun factor, that are important that you can't really judge, and automation can't judge, and neither can someone running a script. So we do a lot of exploratory testing. But we find that in exploratory testing that people tend to do the same things in a game, and they miss objects that need to be interacted with because they don't know they're there. There are certain screens and artwork that they don't even get to see because they don't go down that path, and we need to be able to guide them down that path. So we use a bunch of visualizations in Xbox. This is one I'm going to bring a half a dozen more with me in November that allow us to see, okay, where have I been in this world? Where can I go in this world? What are the objects to interact with on this particular screen? And then cheats, actually, that make the whole idea of testing easier. And I'm going to show you some of those screens as well from some of the games that we have currently under development that will be shipping by about the time we have this conference, and how our testers actually use visualizations and cheats to be better at testing their software. The one on the right is a little screenshot from a tool we call WinRat. It's the Vista operating system. It's a specific visualization of the Vista operating system dealing with code churn. So if you want to be able to go in and test the parts that have changed, this visualization will help you figure out which parts have changed. You know, testing an application like Vista is quite a challenge. When we're live in November, I will give you more details on that, tongue-in-cheek, because Vista hasn't been met with quality acclaim, shall we say. It's so big, it's so large, that without visualizations, it wouldn't even be testable. So visualizations for code churn, visualizations for code coverage during test, visualizations for interfaces that are currently active, interfaces that are not currently active, are a huge part of testing this application. And after we've shipped Vista, we have this massive tooling effort for more visualizations because we understand the spots we missed in Vista and that we need to get right for Windows 7. And I'm going to talk about, I'll show a bunch of different ones of these and talk about how we use them and how I think visualizations are going to be the key to making our testing more effective, because they reduce that analytical time that we need in order to actually plan an effective test. So from where I sit, the inability to visualize our product and their intricacies and their test and their complexities makes software testing artificially complex and unproductive, and we need to change that. We need to be able to see the product as it's being built, not just after it's finished, but as it's being built, so that we can push testing activity far earlier into the testing cycle. And that's going to be a theme of the next one as well, which is my last one. So I've got another 5 minutes perhaps. Bug lifespan. Bugs are born in software, and they stay in there far too long. A developer will type a bug into their IDE and not realize they've done it. I'm convinced that if they realized that they've written a bug, they wouldn't have written it. I may be naive, but let's just go on that assumption for a second. Developers write a bug, it stays, code is manually reviewed, code is statically analyzed, code is then compiled and built into the build. Testers begin to test it. They still don't find the bug. The longer that bug stays into the application, the harder that bug is to find. Now, can we do something about this? Can we take what we do as software testers and push it closer to the actual creation of the bug? In other words, instead of creating a bug and allowing that bug to persist, we move the detection mechanisms as close to the creation of the bug as possible. My analogy for this is document creation. So I've got a few icons on the screen: an old-fashioned typewriter, a circa 1980s word processor, EuroSTAR, and then finally Microsoft Word with its famous little ribbon. I hate it or love it. Actually, it turns out most people love it once they get used to it. I actually have some more insights on that once we're live in the Netherlands as well. By the way, congratulations to everyone in the Netherlands on the Euro 2008 victory. One heck of a game. But I digress. When we're creating documents, back in the old days, of printing presses, you would get an error in a document, and it would be very difficult to remove. Particularly after you printed that document, it was really difficult to remove. We have the same thing in software now. Now, if we look at the way they solved this in document creation, as we went from typewriters to word processors allowed us easier fixes, right? It was easier to find the bug and fix the bug with a word processor than it was with a typewriter. We could take our error detection mechanisms, which in this case are peer review and having copy editors look at it, and we could actually move those forward in time before we actually printed the document. So our bug detection mechanisms moved closer to the actual creation of the bug. And now if you look at the way Word does it now, spelling errors are detected immediately, right? It's underlined in red, and a lot of times it's just corrected for you. Grammar checking is the same way. The second you type that period and then hit space to type the next sentence, the word processor itself has grammar checked your document. So then it can underline it, and while that sentence is still inside your head, right, you've just written it, the context surrounding that sentence is present in your mind. You can fix it instead of 2 days later when you realize, oh, I've got an error here. I don't even remember what I was writing. The context is gone. The bug is much harder to fix. Now, why aren't we doing this with our software tools? Why are we waiting until the application is complete until we're running static analysis? Why are we waiting until we've compiled, built, and have the application in our test lab before we're testing it? Are you telling me that as software testers and the quality control mechanisms and bug finding techniques we've developed over the years are only applicable to a working binary? Why is it that I can't take what I do in testing and apply it to architectures, apply it to designs, and apply it to code as it's being built? These are the sorts of solutions that will take our bug detection mechanisms that we excel at as software testers and move them into the development phase. So I want it to work like spell checkers. Instead of waiting until I finish the document and then running my spell checker, now the spell checker is running as I'm writing my document. Right? I want that. I want my developers to have access to that. I want my developers to have access to the testing tools while they're writing the software, so they can right-click a function and say, test me now. why wait until the program is complete? There's no reason. And in November, I'm going to bring examples of us doing this so that we can talk about which ones might be useful. So from where I sit, the lifespan of a bug is a big problem. And if we can reduce it, if we can move detection close to creation, we are going to actually have a far better chance of reducing the bug population by some substantial amount. So my conclusion. Software will continue to run our economy, our businesses, and our lives. Software will be part of solutions that will grow food, cure disease, and produce sustainable energy. You remove software from this equation, and humankind's problems get a lot harder. It's up to us, as the engineers, the quality engineers in the software industry, to figure out how to solve this problem. I've given you insight into 3 of the problems I think we need to solve: information, visualization, and bug lifespan. I'll bring more with me in November, and hopefully we'll create a dialogue, and as a community, we will fix this problem. My name is James Whittaker. I work for Microsoft, and I appreciate your time. Thank you very much.